I am Dr. Venkateshwara, Professor in Chemistry. I am working at MPR College, Engineering of Technology, and discuss about important questions in first year B.Tech Chemistry. I am discuss about first question, molecular orbital energy level diagram of the CO. Molecular energy level diagram of the CO. CO means carbon monoxide. Carbon monoxide means here mainly two atoms. First atom is the carbon, second atom is the oxygen, to finally combining together CO molecule. CO molecule. So carbon combining to the oxygen finally gives to the molecule CO. That means carbon monoxide. So here energy level diagram of this CO is the mainly based on the two atoms. First atom is the carbon, second atom is the oxygen. I am talking about the first carbon. So atomic number of the carbon 6. Next one is the electronic configuration of the carbon. So 6 electrons. 1s2, 2s2, 2p2. Totally 2 plus 2 plus 2 plus 6 electrons. That one is the carbon 6. Next one is the ground state electronic configuration. That one is the here 1s2, 2s2, 2p2. Actually this one is the 2p cell, this one is the. So here 2 electrons are present, you have to write to the 2p2. So first cell, that one is the 1s2, 2 electrons, 2s2, 2 electrons, and 2p, 2 electrons. This one is the here sp2 hybridization. This one is the sp2 hybridization. Next one is the fourth one. Exist state electronic configuration. That one is the here no change is the 1s2, no change. Here changing the 2s2. 2s2 is the 2 electrons. That 1 electron is the most to the here p orbital. That one is the here 2s2 is the 1s2 is the no change. 2s2 is the only 1 electron here present exist state. Second electron is the here, this one is the X, Y, Z orbital. So this one is the finally 4 electrons. What is the 4 electron? Outer shell electrons of the carbon is 4. Carbon is 4. That outer shell means this one is the single electrons. What is the single electrons here? 1s2, 1 electron. 2px 1 electron, 2py 1 electron, 2pz 1 electron. Totally 4 electrons. This one is the here carbon. Next, atom oxygen, oxygen, atom oxygen. That one is the atomic number of the oxygen is the 8. Electronic configuration of oxygen is the 1s2, 2s2, 2p4. So this one is the 2 electrons and plus 2, 4 electrons and plus 4, 8 electrons. That one is the atomic number of the 8. Next one is the ground state electronic configuration. Ground state electronic configuration. This one is the 1s2, 2s2, 2p4, 4 electrons. So here first cell, this one is the 2x, 2px, 2 electrons, 2py, 1 electron, 2pz, 1 electron. This one is the ground state. Next one is the exist state electronic configuration. That one is the 1s2, no change, but 2s2 here ground state is the 1 electron and exist state is here 2 electrons, here exist state is the 1 electron. These electrons moves to this side. That means finally 1s, 2s1 and 2px2 and 2py2 and 2pz1. This one is the 2 electrons and 2 electrons and 1 electron. Next one is the outer shell electrons of the oxygen. How many? 6 electrons. How to? That one is the here. This one is the 1. 1 plus 2 electrons. 3. 3 plus 2 electrons. 5. 5 plus 1. 6. That one is the outer shell electrons. So here carbon atomic number is the 6. That one is the 1s2, 2s2, 2p, 2 electrons. 2 electrons and 2 electrons, and remaining is the 1 electron, 1 electron. Next one is the carbon atomic number 8. That one is the 1s2, 2s2, 2p, 4 electrons. 2 electrons and 2 electrons, and 4 electrons is the 1 electron, 1 electron and 1 electron. Remaining one is the totally 4 electrons. So this one is the 1s2 and 1s2. This one is the innerly overlapping. This one is the outer shell electrons. Outer shell electrons. This one is the outer shell electron. This one is the 4 electrons. Totally outerly 4 electrons. That one is the 4 electrons outer shell electron. This one is the 6 electrons outer shell electrons. Outer shell electrons, 6 electrons. First one is the, this one is the innerly overlapping. That one is the here 1s2, 2 electrons, and oxygen 1s2, 2 electrons. So that one is the carbon one side and oxygen one side. So carbon is the here 1 electron and oxygen 1 electron, oxygen 1 electron, 1 plus 2 electron. Remaining is the here 1 electron and remaining is the 1 electron. This one is the innerly overlapping. This indicated to the KK. This one is the KK innerly indicated to the overlapping KK. This one is the innerly overlapping. So next, outer shell is the 4 electrons. This one is the 4 electrons. Outer shell is the 4 electrons. So innerly overlapping. This one is the not made. So only outerly overlapping cells. One is the not indicated here. So remaining is the, this one is the outer 4 electrons and outer 4 electrons overlapping. And one is the here. First one is the carbon. Carbon is the how many electrons? 2 electrons. Carbon. Next one is the carbon is the here p orbital. How many electrons? 2 electrons. Next one is the second atom is the oxygen. 2s2, 2 electrons, and 2p4, 4 electrons. 4 electrons. 2p4, 4 electrons. So carbon atom 1s2 orbital, and here also 2 orbital. 1s2 orbital. 1 electron. This one is the 1 electron, and second one is the 1 electron. Second one is the second electron, and oxygen is the second electron. So 2 plus 2, 4 electrons. Here overlapping the 2 plus 2, 4 electrons. Both are equal. So next one is the carbon of the p orbital and oxygen of the p orbital. Carbon of the p orbital 1 electron and oxygen 1 electron. Total how many electrons? 2 plus 4, 6 electrons. So here 2 electrons. Next one is the 1 electron, and next one is the second electron, and totally 6 electrons. 2 plus 2 plus 2, 6 electrons. So remaining before that here 2 plus 4, 6 electrons. Both are the equal. So this one is the here energy level diagram of the carbon monoxide. So this one is the filling the electrons, mainly filling the electrons. You have to write the energy level diagram. Molecular orbital of the configuration of CO. So molecular orbital of the configuration CO is the based on the energy level diagrams. First one is the 1s orbital of the carbon and 1s orbital of the oxygen. This 2 is the innerly overlapping. So this innerly overlapping, that one is the indicated to the, this one is the indicated to the K. Inner shell is the overlapping, that one is indicated to the KK. So 1s1 orbital, this one is the KK. Next one is the 2s orbital of the carbon and 2s orbital of the oxygen is the overlapping. That one is the here. Two bonds is the bonding and anti-bonding. Bonding means here one has sigma 2s 2 electrons 2 orbital. Next one is the sigma star 2s 2 orbital. So this one is the 2s orbital. Next one is the here. So this one is the p orbital. P orbital is the here. Carbon is the 2 electrons and oxygen is the 4 electrons. Oxygen is the 4 electrons. Oxygen is the 4 electrons. Totally here 4 electrons overlapping to give the p orbitals. First one is the carbon 1 electron and oxygen 1 electron finally reduced to the sigma 2 Z2 orbital. Next one is the here totally 2 electrons and 4 electrons, totally 6 electrons. 2. So next out of 6 electrons, 4 electrons is the this one is the 1 electron and 1 electron. So here first one is the 1 electron and second one is the 1 electron, 4 electrons. Next one is the 5th electron, next one is the 6th electron. So this one is the here we have to write the diagram. That one is the sigma 2 pz, sigma 2 pz 2 electrons. Next one is the confusion. 5 2px 2 electrons and next one is the 5 2py and 2 electrons. You have to make it to be equal. Equal means this 2 is the equal level energies. xp 5 2px orbital and 5 2px orbital. This 2 is the equal energy orbitals. That's what we have to make it to the equal. Where is the equal here? 2px orbital and 2py orbital both is the equal. Remaining is the here 5 star 2px 0 electrons, 5 star 2py 0 electrons, sigma star 2z 0 electrons. That one is the multiplicated, right? That one is the here 0 electrons. Here only electrons. Okay? This one is the order. Next one is the bond order. What is the bond order means? Next one is the bond order. Bond order means here number of the electrons in the bonding of the orbitals minus number of the electrons in anti-bonding molecular orbitals by 2. Once again, bond order. Number of the electrons in bonding molecular orbitals minus number of electrons in anti-bonding. What is the here bonding orbital? Bonding means here downside. This one is the downside orbitals. Downside of the anti-bonding means upper side. So here first one is the calculated to the bonding orbitals. So this one is the overall bond order. NB means number of the bonding orbitals minus Na means number of the anti-bonding by 2. So this one is the NB. NB means number of the bonding. Bonding means this one is the downside is the bonding, upper side is the anti-bonding, star anti-bonding. Here this one is the downside is the bonding, upper side is the anti-bonding. Upper side is the anti-bonding. So here number of the electrons bonding is the 2. So this one is the 2. Next, this one is the bonding 2 plus 2, 6 plus 2, 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8 electrons. Next one is the number Na means number of the anti-bonding. Bond order NAB minus Na by 2 is equal to 8 minus 2 and by 2 finally 6 by 2 and 3. This one is the bond order is the 3. Here this one is the CO molecule is the finally 3 bonds. That first bond is the here sigma bond and the second double bond is the pi bonds, 2 pi bonds, one sigma bond and 2 pi bonds, finally triple bond. So here this one is the CO molecule is the here diatomic molecule due to the no unpair of electrons. All is the pair of electrons only. Here pair, here pair, here pair, here also pair of the electrons. That which molecule is having the pair of electrons, that one is supposed to be diamagnetic. Suppose unpair of electron, that one is the paramagnetic. Here no unpair of electrons, only pair of electrons is the present. That one is the only CO molecule source to be diamagnetic.